Okay, so going over the climate change unit, you can see by looking at this graph, areas that are much more higher, let's say in temperatures, these kind of higher areas, okay, of the line, showing you that this is an interglacial period, and these obviously lower areas over here are glacial periods. Interglacial being much more warmer periods in the global temperature, in that time period, and obviously we've had much more colder periods, let's say ice ages, over here. Now we're obviously currently going through an interglacial period, but this is obviously a different time span. Now, very quickly, you can see lots of things fluctuating if you're describing a graph. But again, you could argue that over the last kind of 2.6 million years, that keyword, the Quaternary period, there has been gradual cooling, but obviously temperatures have fluctuated. But more recently, you'd argue that actually temperatures have started to increase, and those temperatures have consistently kind of been going up, especially since the 1950s, and then we link that with global warming. Being able to explain and describe and the actual global effects of climate change, you can look at these photos. You can see from 1979 what's happening over here in terms of ice sheets melting away. Now, thinking about what the effects are in terms of impacts, you could easily argue saying obviously we've got greater increase in rising sea levels, ice caps melting, more low density countries, so like flatter countries like Bangladesh, more at risk. We've got an increase in natural disasters, tropical storms and wildfires because of global warming, increased temperatures. Okay, so these are the different areas you could easily talk about. This one is more about, you need to know a bit about the stats. If you get something about the evidence of, let's say, climate change. So the Arctic ice, okay, there has been an almost 40% retreat in terms of ice sheets, okay, could entirely disappear by 2100. Rising sea levels is more that reports have suggested there has been a global rise of about 10 to 20 centimeters in the past 100 years. And seasonal changes have come out in showing that actually tree flowering and let's say migration of certain animals like birds have been much more earlier, and these are all signs that actually climate change impacting different parts of the world in different areas. Evidence of climate change in terms of how that is extracted. You could argue the ice cores over here, so almost looking at this ice core over here, giving you different time periods of the world. Maybe this darker line over here on this ice core is a much more industrial period. So these samples are used to see kind of global temperatures from ages ago, and they can analyze the kind of level of CO2 levels amongst these kind of, let's say, ice cores. And tree rings obviously show you, let's say, in warmer, wetter years, the tree rings are thicker. So thicker tree rings show that actually in that time period were, let's say, a warmer, wetter period, and that reveals kind of like temperature history over time. So natural causes of climate change, one of them is being the Milankovitch cycles. The Milankovitch cycles are these three different areas that was studied, showing that actually the Earth's temperature, global temperatures can change naturally, okay, because of changes in the orbit. The first one being, let's say, eccentricity, this idea over here that Earth's orbit around the sun is not exactly fixed, okay? It can move from this elliptical, so this oval shape, to this kind of more circular shape every 100,000 years, and that could impact, let's say, climate change because of the amount of sun's rays it receives. So we might have, let's say, warmer summers or something. Then we go on to, let's say, the axial tilt. So Earth's tilt actually can, let's say, change between 21.5 degrees and 24.5 degrees. It's currently on 23.5 degrees. But because of the natural changes in, let's say, in the tilt, that could definitely impact, let's say, certain areas receiving more solar radiation, and that could lead to, let's say greater kind of levels of ice caps melting. It could lead to like areas becoming much more colder as well. And then we've got this last one called precession, which is actually this idea, because of gravitational pull, naturally there is a wobble in terms of Earth's orbit, and that can also impact, let's say, the levels of rays received from the sun, generally all linking back to this idea that temperatures can change. Another natural cause of climate change is sunspot activity. Now, the word you'd have to mention is this idea of sunspots. Now, the sun's surface can often have these dark patches known as sunspots. Now, when there is quite a few of them, we call that maximum sunspot activity. Now, that releases a lot more heat, so that could lead to more warmer summers. So the sun, provides more kind of solar activity, really, resulting in solar flares. Now, often that could also result in, every 11 years that varies, and it can go down to, let's say, minimum solar activity, sunspot activity, and that has led to, in the past, ice ages within Europe. So it's not always warm, or to one extreme, it can also be quite cold because of a lack of, let's say, sunspots. And the last natural cause of climate change is obviously volcanic eruptions. Now, thinking about how you might answer this, now a huge volcanic eruption can result in obviously a large amount of ash being produced. And now in some areas, that has actually reduced the levels of let's say solar radiation, let's say the sun's activity, resulting in much more colder temperatures, so kind of almost ash blocking out the sun. And we also spoke about how the sulfur within, let's say, volcanic minerals has led to them acting as tiny mirrors. So the sulfur dioxide turns into sulfuric acid, and that led to, let's say, huge crop failures because of a lack of activity from the sun. We called it a volcanic winter. An example you may have studied was obviously Mount Tambora, which led to huge devastation amongst Europe, in terms of what happened. Crops failed to grow, food prices rose, and it was one of the harshest winters experienced in Europe. Human causes of, let's say, climate change. You must talk about the greenhouse effect. So I'm just showing you a picture of a greenhouse and how actually Earth is exactly symbolic of that. So in terms of heat can easily enter the Earth's atmosphere, but actually it finds it very hard to leave. And why does it find it very hard to leave? It's because of all these gases such as CO2 and methane. What they do ultimately is trap this kind of solar radiation, and obviously prevents it from leaving, keeping Earth warmer. Now that's obviously needed, it is vital, but now we have kind of almost an excess amount because of humans, actually, isn't it? So we call that a blanketing effect. So when you're talking about, let's say, human causes of climate change, which I'm going to go through right now, make sure you link it back to the greenhouse effect, the enhanced greenhouse effect. Blanketing effect, it's like a blanket. It's preventing, let's say, the heat to leave, which is good, but we have too much of it now, where we're seeing terrible things such as, ice caps melting and more intense tropical storms and wildfires. So human activities for CO2, now obviously this is one of the biggest drivers of, let's say, CO2 emissions or greenhouse gas emissions. Now CO2 accounts for about 60% of all greenhouse gases. So there is obviously increased population, whereas resulting in kind of increased energy demand, linking it back to, let's say, power stations being one of the main drivers. We've got obviously car exhaust fumes. Petrol and diesel cars amount to about 89% of, let's say, for CO2. We've got average car ownership is also quite high in many areas. Another easy one to talk about as a human activity for, let's say, climate change is deforestation. Now, you know that trees act as carbon sinks. Now, because of, let's say, various reasons, trees are being cut down, and that obviously means the absorption process for them to act as carbon sinks is now removed, resulting in more CO2 just being kind of almost hanging around in the atmosphere. And also you could argue that trees obviously store carbon. Now, cutting them releases all that stored carbon. Rice farming is one of the biggest drivers of, let's say, methane kind of levels. Now, methane counts for about 20% of all greenhouse gases. Now, methane being, let's say, almost more deadly. Now, how does it come around? You could talk about how, because of waterlogged conditions for rice farming, there's a huge demand for rice, obviously, around the world. The bacteria in the waterlogged conditions result in, let's say, large amounts of methane being released from rice farming. And lastly, talk about obviously livestock and cattle farming being one of the biggest drivers of, let's say, methane levels in the atmosphere. Obviously, let's say the digestive system of cows especially, release large amounts of methane, and that obviously is one of the biggest drivers of climate change as well.